Alright, it has been a long day of school. I just need to relax and play some Fall Guys. Another chem assignment? Record a video explaining excited electrons as if the viewer is a 5-year-old. How would I even begin to explain that? Oh, well, I guess Fall Guys could work. For those of you who don't know, Fall Guys is a video game, and yes, I'm really doing this. Alright, so I'm now in game, and as you can see, I've made a diagram of an atom. Now, an atom is basically made of 3 parts. There is the proton, the neutron, and the electrons. So the protons and neutrons are very tightly compact, and so that's what that green thing is over there. And the electrons are more spaced out. And those are the yellow things you can see following those purple rings. Now, these purple rings actually do matter. The further a ring is away from the protons and neutrons, the more energy it's going to have. So already the 4 electrons on the end, which are called valence electrons, have more energy because they're further away. But if we wanted to have more electrons have more energy, then we need to get the sun involved. Because the sun, which I made over here, has these things called photons, which is literally just a packet of light. That's what this little cute little guy is here. So I'm going to explain how the photons affect the electrons, but first I want to give a little demonstration. Oh boy. Okay, let me explain what just happened there. When I turned on the sun, a lot of photons got shot at the atom. And that caused the electrons to absorb those photons and then blast away from their normal location, called the ground state, to rings further away from the protons and neutrons, called the excited state. And sometimes more rings can even be created for this to happen. Now, here's a cool side effect of all this. The excited electrons can't stay excited forever, and they eventually have to let go of the photons they absorbed. And when this happens, they obviously go back to the ground state, but also the energy from the photon gets let out as light. So now let's go back to our diagram and see what really happened. What happened? Where am I? Oh, 2 electrons here. I guess this is the perfect time to explain electron configurations and which colors get shown. Alright, let me back up a bit. As most of you guys know, color is on a spectrum, where if there's more energy, you'll get more of a red color, and if there's less energy, you'll get more of a purple color. But how does that get shown for atoms? Well, carbon has an electron configuration of 2, 4, meaning that there's 6 electrons total. 2 of them are on the inner ring and 4 on the outer ring. And that's the atom that we used earlier, carbon. And then there's the atom on the right here. This one has an electron configuration of 2, 2 because there's 2 electrons in the middle and 2 on the outside. And because there's more electrons that are on the outside for carbon here, then carbon is going to have more energy and therefore more of a reddish yellow color compared to beryllium's green and blue. What does this matter? Are there any actual uses for this? Well, there is fireworks. Alright, I finished the fireworks. Now all I have to do is ignite it like that. And you can see all the atom particles down there. All the electrons have exploded, and there we go. That looks so cool. Whoa. Ow.